And you can see my screen?
Yes. The screen, I cannot see the screen.
Oh, you
Maybe
cannot
it's
see the
already
screen.
unshared, yeah.
Oh, sorry. Okay, bear with me. Just hang on. Okay, great.
Okay, let me start with introduction first. Okay, so Bismillahirrahmanirrahim. Our honorable guest, our honorable speaker, Dr. Asim Gauss, the director of Maplesoft Asia Pacific, professors, lecturers, beloved students, and all participants in this webinar. Assalamualaikum and good morning. Okay, before we begin, let's start with a recital of Al-Fatihah. Okay, welcome to the international webinar, Future STEM Digital Education with Maple and MOBIUS 2022, organized by the Center of Excellence, UiTM-Maple, and also Maplesoft Asia Pacific. I am Dr. Normi Abdul Hadi, will be served as the moderator for today's webinar. So before we get started, okay, I would like to go over a few items for today's event. For your information, this event is broadcast through two platforms that are Webex and also YouTube channel, Center for Mathematics Studies, UiTM. Okay, so the training hours will be given for all UiTM staff who submit the event feedback form. The link for the form will be shared at the end of the event. Okay, and then the audience will have the opportunity to ask text question to the presenter by typing your question in the Webex chat panel and also in the YouTube comment section. You may send in your question at any time during the presentation. We will collect and address them during the Q&A session at the end of today's presentation. Ladies and gentlemen, Maple is not a new software. It has been utilized in UiTM since 2006. In 2022, Maple launched its latest version and came with an interactive learning platform, which is MOBIUS. Therefore, this webinar aims to introduce and give an overview of the latest Maple and MOBIUS as a platform to support future STEM digital education. Therefore, for today's webinar, we have invited an expert to talk about the new features of Maple and MOBIUS 2022 and how it can support future STEM education. Let me introduce our speaker, Dr. Asim Gauss. Dr. Asim Gauss obtained his PhD from the University of New South Wales, Australia. He has been associated with Maplesoft for more than 15 years. Currently, he holds the following position: the Director of Maplesoft Asia Pacific, Asian and Middle East region, the Vice President of Digital Education Asia, and the Director of ASES for Asia Pacific, Asian and Middle East region. Therefore, without further delay, let's welcome Dr. Asim Gauss. Dr. Asim, the floor is yours.
Thank you very much, Dr. Nomi. I really appreciate it. And thank you very much for organizing this webinar. On behalf of our corporate, I really extend my gratitude to the UiTM, the Center of Excellence, for organizing this wonderful webinar. And we hope that in the next sometime when we're with you, we will be able to sort of showcase some of the tools that we have. Now, I'm also joined with one of our engineer, Raymond Liang, who will be later on running the product demonstration once I have finished with the introduction. Now, I guess Dr. Nomi has well said in the introduction that Maple is not an unknown tool to UiTM. UiTM has been utilizing Maple for quite some time. So if the newcomers in the meeting, just to give you a bit of a history, that Maple is a mathematics-based software, and the manufacturer of the tool is MapleSoft. Now, I'll be able to sort of portray, how we see the STEM education when it comes to delivering the lessons, the assessments, and also the other aspects of education. Before we go into the tools, let's look at what are the current status of education really is. And I'm sure from the academia perspective, all of my colleagues from UiTM fully understand the challenges that we currently confront with delivering digital education, or I should say STEM digital education. From our perspective, with the recent COVID wave, that has actually has brought in a variety of issues that has been the challenge in the educational market for quite some time. From our perspective, the STEM education is obviously the core in education sector. And for those who are fully aware of the word STEM, it stands for science, technology, engineering, and mathematics. From the overall education perspective, these are some of the areas that we think that are very critical as we move towards the future of education or future of STEM education. The blended learning, as you can see on my slide, is obviously a very key element. What we are hearing from the academia is that it's not just that you deliver education in an online space, but it has to be blended. You need to have the tools which can give you the ability and functionality to deliver your contents in an online and also in the classroom presence. So even though that we have experienced a couple of years of lockdown as globally, we realize the importance of remote access to these contents, but still with now conditions getting better and students are returning back to the classroom, we think that our tools are fully prepared to deliver a 100% online or even 100% blended format. So whether the students are in classroom experience or the students are outside the classroom, off campus, they can still utilize the contents that the instructor has developed. So really, the blended learning is a very key element in our tools. The other thing which we think that is very critical, for delivering STEM education are the contents. Contents are such an important thing from an individual learning perspective. Every student is different from learning side of things. Every person has a different learning needs and different learning spectrum. So the contents are there which can be delivered in an online space or a digital space, and as well as those contents are available to be utilized in face-to-face learning. So really, it sort of gives you the ability where the content can be tailor-made for a classroom which is either on campus or off campus, as well as the instructor can actually see how that content has been delivered on an individual level. And again, with the institutions are going almost online, again, I'm going to sort of repeat the same remark that even with that online presence, in our tools, the instructors and the students have the ability to access those material in both modes. This is an interesting graph that I wanted to share. That some of the attendees must have seen this graph in my previous presentations, but this is an interesting challenge that we have. This graph actually shows, if you see on the left, it's a 6 days data recording, and be able to see that how students have been performing in the classroom. Now, surely we can apply similar analogy in an online environment too. If you look at the graph here, it actually tells you that from the student engagement perspective, students are very less engaged in the classroom. Their brain activity, these graphs are brain activity during the sleep mode, during the class mode, and during the study mode or watching the TV mode, and the lab. So you can see the brain activity is pretty flat, obviously, when you're in a sleep mode, and the brain activity is pretty flat when you're watching TV. And unfortunately, the brain activity is also very flat when you're in a classroom. So that shows that how students are actually lack the engagement with the material or with the instructor. And I guess you could probably say that it's a kind of the nature of theory or the nature of STEM contents that we deliver in the class, which doesn't have the kids fully involved or fully engaged. Whereas if they're in an exam mode, or if they are in a lab mode somehow on the top level, or they're in a study mode, or when you give them a homework and you say, you do this now, you can see how they actively think, how their brain activity goes high, which highlights that we learn by doing. If you give them something to do, they will start thinking and they will start getting engaged. So really that study actually shows that we learn by doing things, as opposed to just simply listening for a long period of time. So really, this is a challenge. Again, what our tools, which we're going to showcase later on, will give the instructors the functionality to develop contents which can let the student to learn by doing things, as opposed to being in a relatively sleep mode in the class. So with that said, the question is open. Really, it's an open-ended question. How do we approach our learning techniques where we can actually have the student engage in learning? And as an instructor and as an academic, we could measure the learning curve and the kind of material that we're presenting, whether it's working or not working. The way we see that is that it's a modularized approach. There's a different modules that we need to approach to that. One is that the learning has to be active, right? So that the students can learn by doing things. And one part is very important in that active learning, and that's called exposition. When you're trying to present a STEM concept, being it's a maths, or being it's stats, or being it's physics, or being it's general science concept, exposition is a very important element in it, which means you present a concept, it has to have some sort of a storytelling in it. So with the storytelling, students can be engaged, and that exposition can take place. The next module is the exploration. Well, you've presented a concept in a storytelling manner, but then you need to let the student to explore things, again, because we learn by doing, right? So the content has to be dynamic and interactive if the exploration has to happen. Once the student given the ability to explore the concept, more likely our content is gamified or simulated. With that simulation and gamification, a student can explore that very story that you actually explained, or the story that you told in your exposition module. And once the exploration has happened, you need to give the student practice and drill, right? Because the exercise is very important. It's a practice that the students need once they understood the concept. The more practice they do, the more drill they do, the better they will be in conceptual understanding. And all of that practice and drill has to be in real time, right? So when the students do their assessments, when the students do their exercises and drill, it has to marked and graded instantly. And it has to be presented to student instantly. So for the feedback, the student doesn't have to wait for 6 weeks or 8 weeks by the time they completely forget what they did. So practice and drill has to be there, but in a real time. Instant feedback and automated grading is going to make that practice and drill much more fun. And once you have developed all of that, once you have done those 3 modules, the last module will then be that you need to produce that analytics as an administration or as an instructor, because you would like to see that whether those techniques that you have actually used have they worked or not. So the ability to see those analytical level to sort of change things and modify things in your future offerings, those analytics are very important. And what we refer all of that, if you put all of those modules together, is what we refer that as a MOBIUS in our platform, which is developed on the technology of Maple. So really, how do we capture all of those modules then? Well, we capture in those modules. We do have other challenges when we capture those modules. Well, the first thing is that we need to have a world-class maths engine, and that's the story of Maple in it, what we mentioned earlier. Because once you have a world-class maths engine, which comes in a Maple form, you have the ability to construct your STEM complex material with an ease. So as an instructor, as an academic, you don't have to be a programmer to do that, because Maple will allow you to develop those contents instantly, easily, with very less programming. Again, as I mentioned earlier, that the immediate feedback is going to make that practice and drill a lot of fun. So our tools will give you that immediate and meaningful feedback, which the student can utilize and gear and steer towards the right direction. The contents has to be a high quality contents with the current digital space. By using our tools, you can construct that high level engaged content, so the students will be engaged with the content. Remember the point I made earlier, exploration, so they can explore it, they can learn by doing it, so then you can actually make a progression, and you can capture that progression in your material. Multimedia visualizations, we all know that. When you see things, when you visualize, a complex concept, it makes the story much more easy to understand because it's visual. So we supply you those tools, which makes that visualizations a lot easier. And then you go beyond in terms of simple testing. In order to test students' concepts, it's very important that you give them some sort of interesting questions, algorithmically generated randomized questions, which can minimize the cheating factor, which can also minimize the guessing factor. A traditional way of multiple choice questions is obviously have a setback of guessing the answer. So MOBIUS and Maple takes things beyond that, and that's where the contents can be much more, or the questions will be much more interesting, where the algorithmic generated technology will allow the instructor to design some interesting and advanced questions for measuring the output of students' understanding. And then with all this system that we are referring to, it has to be easily, seamlessly integrated with the LMS system. And I think, to my understanding, we are having an active conversation from that current implementation that this system, such as MOBIUS, or even MOBIUS, which is developed on top of Maple, can be integrated with your UiTM LMS system, the learning system that you currently have. Now, with all that technology that we're referring to in terms of Maple and MOBIUS, two products in one umbrella, it's completely a SaaS-based platform. It's an online platform that you can simply log in and you can access anywhere on any device. And your institution will have control on your courses. It's very important, as I mentioned earlier, in terms of contents, the institution will have a very controlled digital IP copyrighted material that you develop. It will be your courses, your way, your contents, your way. So you can set up your rules as an institution rules or as a faculty rules, and our tools such as Maple and MOBIUS will give you the ability to construct that material under your own digital copyright umbrella. Mentioned earlier that it has variety of advanced assessment techniques, advanced question types, that the platform offers, and some examples will be shown later on. It gives you a full flexible formative assessment techniques. It combines the slide transitions, the voice recordings, interactive narratives, and you can develop those contents which are much more engaging. It gives you a complete control on how would you like to deliver your assessments and quizzes and exams, basically, in a very secure and in a lockdown browser environment with the Proctor tools that we supply. Right. So what would you see in our tools? It's easy to use. They are, you can navigate through that fairly easily. It has the content, it has the gradebook, it has the analytics, and it has a whole bunch of additional resources. It gives you the access to both of the worlds. You have a lot of open-ended, open educational resources that we give you as a free access to it. And on the other hand, you also have a copyrighted material content that is digitally unlocked. So you don't really work in a locked environment. It's a very unlocked environment so that you can clone, modify, change things the way you like. And even though that we give you a lot of content and resources, those could be deployed instantly in your own controlled environment. So as an instructor, you have a fully controlled on the local IP of the material. So as I mentioned earlier, that it does give you access to the open educational resources. That's one of the options that's available out in the market. But the resources that currently are outside the MOBIUS space, it does have some setbacks. You don't really get a full support with it. And those open educational resources do lack the advanced STEM capabilities. And when I mention STEM capabilities, it means the ability to construct and insert complex notations, complex simulations, interactive narrative elements. Those elements are does lack in your open educational resources. If you go to the different trajectory where the publisher textbooks are available, if you go in that, one of the biggest setback in publisher textbook model is that they generally are locked. So even you actually subscribe to it or you adapt to it, you can't really change things. We understand every instructor has its own delivery style. Every local instructor have local delivery needs and requirements. So when it comes to publisher model, that lock mechanism in it doesn't really make things much more flexible. In MOBIUS, it gives you the full access, as I mentioned earlier, that they're completely digitally unlocked, and you can basically clone and modify and custom build your own contents. You can pick up our content and make it to your local needs and local requirements. And some of the open educational, the publisher models do lack advanced STEM notations. And Maple comes into the picture because Maple is much more easy to use, clickable environment for STEM education. So really, when you look at our tools, you get both of these, both of the worlds. You get these open content packs, which are professionally designed. They are interactive STEM contents. They've been authored by the discipline expert. And those contents have been actively used at the universities across the globe. And along with that, you get yourself access to the platform because you do need the access to the designer space. You need the access to the platform so that you have the designer tools so you can design and style things which can fit your local need. So we give you the access to both of those. This is an example to begin with, is that it gives the environment where your contents will be just like one of these examples. And we'll show you some more examples as we move forward, is that where you have lesson structure in a digital space, visualization, simulation is given with it so that students can learn by doing, and that interactive material can make that understanding much more easier for complex concepts. These are some of the list of the packs that we currently have, and they are growing. Later in the next few months, we are actually releasing a lot more content to cover a lot of other areas of STEM. And now we are extending our usage in chemistry, in even electrical engineering, mechanical eng, and we have some examples in those disciplines as well. Some of those premium content spec that we have, which are highly interactive for the course material, they are available online, and we have a whole list of that, something that I would like you to refer to if there's anyone who's interested in those premium topics. Right. The LMS part of that is fairly interactive. When it does integrate with your local learning management system, the instructor can actually navigate through the local LMS system based on a single sign-on functionality. You don't deal with multiple username and passwords. When you log into it, it simply gives you the links, and those links can be used part of your navigation, right, for your assignments and lessons. So you can see that even in your local LMS systems, you won't be able to lose the navigation of that local LMS system. All that material that we supply you or your instructor construct from scratch will just be available in your LMS space. So, but why do you need both of those? Is because your current LMS does not have the mathematics understanding. It does not have the equation editors that the STEM education needs. It does not have the algorithmic randomization functionality. And it does not have the interactive and graphical question types. So when we supply you these tools, you can actually make your local system into a completely STEM engine, which a lot of instructors at the Faculty of Maths or Faculty of Engineering would admire those tools for their day-to-day delivery. Okay, with that said, just some of the examples will be, I'm just going to go through some of the examples from here. As you can see, the interface will become a lot more interesting for you when you develop your assessments by using Maple and MOBIUS. Your traditional questions will have the understanding of how the natural maths is presented. So this is how the equation editor will appear in any device, regardless whether a student is using a phone or tablet. That equation editor is as if you're entering a natural maths. It will have the authentic notation, so that as if you're using pen and paper, as we learn, and it will have the resemblance when you enter an input. It could be read as a natural input, which is as good as your pen and paper. It will have a very easy to use generation of algorithmic randomization, and you don't have to be an advanced programmer for that unless you want to go into the deep end. That's a different matter. But we give you the access to a designer platform, Show Designer platform, as you can see here. It will then help you to construct algorithms around your material, which can run again for eternity, basically, because every time the questions or the assignments that you put together as a question repository, when those questions have been generated, it will generate different values for those numbers which has been declared in the algorithmic section of it, which obviously reduces the cheating factor of that, because every student will get a different value, and they just can't copy and paste their answers to it due to the different values that. Yet the concept will still be the same. The area of the topic or the question that you're addressing is still on that same level of complexity. So you're not really compromising the level of complexity in that. You will have, as I mentioned earlier, not just in your lessons, but your assessments will become a lot more interesting. And these two types of assessments that you can see on the screen, this is very popular in physics, where this is a force body diagram, and this interactive questions can be used for designing the concepts where forces have been measured. So you can ask students to measure the tensions or forces or gravitational forces, and student can answer those questions interactively. This is a sketchable pad that is available in the tool, so you can design your questions and ask the students to sketch something, and they can sketch the curve or they can sketch the plot, and then this will be marked automatically. You'll be given a variety of control panels, as you can see here, with that control panels and sliders, basically. Once the students engage in those sliders, you will see that the dynamic graphs and dynamic plots will make that as a simulation, which will make the learning a lot more effective. You can have a multi-part assessment, or basically what we call it as an adaptive sections. So you can give the student a certain question and then measure the understanding, measure the feedback. And if the feedback is wrong, you can actually break down the problem into multiple steps to make sure that the student actually understands the prerequisites. And once the prerequisites are covered, you can then steer the student into the next steps to make sure that before you go into the complex problem, students understand the fundamental steps involved in that. And that's a very good example. When we learn integration by parts, that can be done in an adaptive grading mechanism. So because integration by parts is involved multiple parts, and it has to break down into multiple steps, students will be able to sort of answer. It will be graded automatically. The feedback will be presented. And in terms of correctness, if their answer is correct, they can go to the next level or to the next branch. But if the answer is wrong, you can again break down the problem and take the student a step backward to make sure that the adaptive progression has happened in the course. Many types, I mentioned that earlier. It has many types in the platform. And once we get to the content repository section of this presentation, we'll probably show you all of these questions that's been used in engineering. Variety of the engineers use these kind of techniques in developing those contents and the assessments itself. Our tools are used across the globe, and this is a recent stats for our online platform MOBIUS, developed on top of Power of Maple. 400 plus schools being used across the globe. 440,000 class enrollments been made, and 35 million automated graded assessments have run through the platform as of the last month of May 2022. Okay. Now, with that said, with setting up the introduction to our platforms, I just want to take you through some of the resources that we have available online before we take you into the platform, or before we take you into the Maple and MOBIUS as a tool. This is where we mention our resources, a whole bunch of resources that we have. What's been introduced earlier with Maple, this blue box represent the variations of Maple. Maple, the core kernel of maths. We also have from Maple a Maple calculator. That Maple calculator is really a magic, because you can actually have a very strong, and it's, by the way, it's completely free. There's no subscription to it. Once you go online, you get yourself download the Maple calculator app, and you can actually use camera to capture your maths. And once you use your phone camera to capture your maths, you don't have to type maths anymore. Once you've captured the maths, you bring it in your desktop. As long as you have a copy of Maple then on your desktop, you can basically get through the detailed analysis. But if you want to do some of the functions that you want to do just on a calculator, just on your phone, you can do that. So you can download Maple calculator easily on your phone, use a camera to capture maths, and then solve the maths by step-by-step solutions. And be able to do that fairly easily. So I strongly recommend that you should go online and download one of this Maple calculator app from App Store or Google Play. And as I mentioned that earlier, there's no subscription to that. It's all completely free for university staff and students to use that. With respect to the other variations for engineers, if there are a number of engineers in this seminar, you can, and this is sort of a bit of out of scope for this presentation, but there's a Maple Sim, which is a simulation environment of Maple. So you can construct a lot of circuit-based system models. You can develop physical models. You can develop, electrical, mechanical, and also, heat transfer systems, which you can definitely explore that here. There's a whole variety of disciplines that we cover from the system level modeling perspective. So from your use, no matter which discipline of engineering, which discipline you're coming from, we have a whole list of models that you can actually visualize. And for that, you don't have to install Maple or Maple Sim on your machine. These models are available completely online if you are coming from that background where the circuits have been given online, and some of those models have been available online to actually see how those models have been developed. And these models are all mathematical models, by the way, because they've been utilized the Power of Maple 2022, and by using the Power of Maple 2022 and Maple Sim 2022 environment, you can actually construct very, very highly developed physical models. And again, they're not just limited to the robotics area, but there's a whole automotive area, aerospace area, and you can actually see a whole lot of very system level models that are available online for you to browse and look at how they've been utilized. This is one of the interesting excavator model. You can see the circuit diagrams have been given for part of your learning, but once you run the models, these models are available online to visualize that. Now, in order to edit these models, or in order to modify these models, or in order to construct new models, you would require a license of Maple and Maple Sim for that. Right. With that said now, what I'm going to do now is to basically just power up, as Dr. Nomi mentioned earlier, some interesting aspects of Maple 2022 before we go into the MOBIUS. Maple 2022 again, it's a great product. People who have been using Maple for quite some years at UiTM, they could realize the interface for that itself. But really, the whole idea of Maple is to supply you with ease to use maths and ease to use concepts where the engineers can utilize their contents and be able to develop that in a teaching and learning environment instantly. Okay, so the interface for the beginners is still the same. I mean, there's nothing really. You can type things and you can see that it could actually be able to visualize instantly. So typing maths and creating an interesting visualization is that you don't need any programming to do when you use Maple in your classroom or in your research or in your assessments. So you can see that as soon as you type maths, it actually visualizes maths automatically. And this is where the power of Maple really is, that you don't really, for a clickable maths and clickable engineering, you don't need too much of system level knowledge. You can just start typing material, and your text and maths and your visualizations and your plots and your graphs will become part of your document. The smart document interface allows you to do that. The other very interesting feature that we always mention is the ability to learn step by step in Maple. And a majority of you guys must have known that. Majority of the academics must have seen it. But if you go into the tools and you say, look, I really wanted to learn a step-by-step functions, it really gives you interactive tutors. And you can now go through the step-by-step learning. So it's not just about jumping on solutions, but it's also about realizing that how the learning could become a lot more effective. So you can go and the system can give you an instant feedback part of your learning process. And once you've done that, you can insert your solution in your document, and that document could become a lot more interesting as part of your teaching and assessment. So really, this is what we refer that when you do things, it makes things, it makes the conceptual understanding of a core concept to as if we are learning in fact, it takes things away than pen and paper, because effectively drawing a 3D graph of a quadratic function is obviously very difficult to do that on a piece of paper. When you use Maple, it could just make things fairly easy. In 2022, there are a whole bunch of new math apps have been added. So a variety of disciplines have applications which are developed in Maple now. If you have the copy of Maple 2022, you'll be able to see that some of those apps have now covered a variety of computer science areas or electrical engineers areas. And those apps are completely built in Maple. So from the aspect of teaching real-time applications, Maple is an excellent tool that you can actually use that in part of your lessons, or creating what we call it as a non-package based or non-programming based, where you can actually develop an interesting apps like that when you teach complex concepts. So this is one of the concepts that the electrical engineers use that for the depletion zone when they teach variety of circuits, variety of P-type and N-type. And you can see that teaching concepts like this where the battery charge is there, and these examples will become a lot more interesting to teach and a lot more engaging, and the simulation makes things fairly easy to understand. Right. So Maple 22, again, very friendly environment, very interactive environment, and it can allow you to develop some of your applications yourself by using the math app animations, and you can obviously use your the previous applications that you developed in Maple, and you can develop a lot more interesting palettes, user palettes, and construct your apps around it. Right. With that said, now what I'm going to do is to pass on the presentation to Raymond. I think Raymond will have a plan to show you MOBIUS showcase classes and some of the more question types and the content repository. So over to you, Raymond. We can't hear you, Raymond. Are you? Can you unmute your? Dr. Nomi, can you hear Raymond? Mike? No, we can't hear you. Okay, maybe you can log out of the Teams and come back in the meet, but while I'll share my screen for the time being. I will let you. Yes, no worries. I will share my screen back again to continue while Raymond will join back again. There you go. Okay, so really, in order to showcase some of this material that we mentioned earlier in an online space in MOBIUS, this is a key differentiator. This is now, if you see that we are sitting in an online space, and one of the examples that we generally give in this classical concept of Taylor series approximation, this lesson is being developed in MOBIUS, which has been taught for centuries. This has been taught in the universities for many, many years. The advantage of using Maple and MOBIUS is that you can use this concept and you can gamify it and create a simulation around it. So Taylor series approximation, as you're well aware of that, it's a very core concept in STEM courses, whether you're doing a first-year engineering course or you're doing first-year maths course or communication course or electrical course, you'll find that this is going to be taught. And if you go into Google, you'll find almost millions of documents talking about Taylor series approximation. But teaching this concept in a PDF format or a static format is not going to be as fun as teaching that concept in MOBIUS and Maple. For example, when we talk about this Taylor series of a function f, students could understand that function f, and we've presented the expansion x naught in an infinite sum. Once we give the student that exploration module, remember that earlier in my presentation I mentioned that when you actually give the exploration part of it to the students, it will make the concept a lot easier to understand. Once they see that it's a sine wave in a Taylor series approximation, a sine wave because the function is a sine x. So sine x, this is a sine wave. They can now basically interact with this material by utilizing the control bars. So they can see how the expansion point can change into the negative plane and the positive plane, right? Negative and positive. And the order of expansion will actually change as they move along and change the order of expansion. And now they can see how the sine curve is actually modifying in that simulation, in that plot, to be able to make a resemblance to the theoretical concept of that. Once this has been given to them, you can now give them an understanding point, making sure that they understand that concept. Now, you can pose them a question. Again, that question could be to make sure that did they understand that. So when the expansion point is x naught, making this a Maclaurin series, what is the error of order -1 approximation at the point theta equal to pi over 2? Now, when that question is given, the students will now be able to sort of enter the answers to it. And once they enter the answers, for example, the instant feedback will be given. And once that instant feedback is given, you can see that instant feedback is actually telling the student whether it's correct or wrong. In this case, it's a wrong answer. It also hints them that, look, notice in this case that the order -1 approximation is simply the line tangent to the curve at the expansion point. So that feedback is completely customizable. Once we go into the editor, you'll see that this section is fully in control by the instructor. You can make a text feedback. You can actually bring equations into your feedback. You can actually bring in plots into your feedback. And that feedback is just an editor that you can make it as many, you can explain that feedback as much as you would like. You can then insert, further to that is that, okay, again, for an expansion point of x naught, what is the error of order -3 on the theta pi by 2? So you can see now that here, again, a text input has been given and the student will be asked to actually enter that and then get that instant feedback. And if the student needs a number help, you can actually supply an appropriate help. That help could be a unit help, that could be a number help, and that help will be something that the students can actually utilize as part of their assessments. Right. The other thing that you can do then by using our technologies is that you can actually develop a lot more interesting and interactive, assessment, right? What we mentioned earlier. Like this is again a concept that we picked up that we've been learning for centuries. The solar system that you normally teach in a first year school or a high school level, and explaining students with this variety of planets in the solar system, which is a very descriptive writing. What you can do is that you can insert a very interactive assessment, and in that very interactive assessment, you can now have the ability for the students to actually click and drag and drop the planets onto the right appropriate blocks to see whether their understanding will be correct or not. So you can then allow them to the system will then be marked as it says it's a partially correct answer. And if I zoom my screen on the right, because I didn't answer correctly, the system has the functionality to mark that question in a graphical way. And you can see that how that question is not partially correct. And you can then have an appropriate feedback to it. So the other thing will be, again, surface area that we've been teaching in our classes for many centuries now. With the MOBIUS and MAPLE, you can construct a simulation which actually teaches a student what that surface area is for function fx. When they run the simulation, that concept makes completely animated. So you can actually supply the traditional narrative to it. Can you all see my screen, Dr. Nomi? Okay. Just want to make sure that you can. Yeah. Okay. So you have the surface area simulation which has been given, and then you can actually have the embedded videos and audios. In this case, this is the surface area example.
Surface of a car.
So you can actually dub your. I'm going to sort of mute the narrator. The lecturer is explaining. You can actually dub your own audios. You can actually use our material, and you can dub your own local audio in your local language, for example. You can create online slideshows where you can actually pause and ask the students a variety of questions. So you can click on continue. You can have a continued solution that you're trying to explain in your lessons, and the student, the lecturer is explaining things in a step-by-step, and you can see that natural step-by-step maths is where you can actually use in a live slide. You can see in the slideshows, the navigation is fairly easy. You can actually navigate the slides to jump onto. For example, if you're in a playback mode and you're running that lecture not live in the class, but you're learning or you're using that lecture in at home or in a cafe, for example. So you can run that material at any time on demand, basically, because it's been fully recorded. Okay, you can actually see all slides. If you click on it, it will then give you all slides, basically. So you can see all that slides in a printable format. Some people may want to sort of download those slides and then be able to have that printable format. Someone said that they can't see my MOBIUS screen. Okay, I apologize because no one actually mentioned that. I thought that, okay, bear with me. I think it was something. Raymond, are you ready to share your screen? Okay, so there you go. Sorry, I apologize that you couldn't see that. Sorry, so there you go. So this is what I was mentioning earlier, that in terms of that surface area, this has been presented in MOBIUS, and this simulation that I was referring earlier. So let's go back a few steps. So Dr. Nomi, can you now see my screen with the surface area? Yeah, in MOBIUS? Okay, very good. So what I was mentioning earlier, that this surface area examples and exercises, now they are in a printable format. They are actually live. You have a highly visual elements involved in that, step-by-step learning, navigation easy, and then in that slideshow mode that MOBIUS allows you, you can go back into a slide-by-slide, or you can go into a navigation mode. You can then insert an assessment question. You can now say that, okay, we have talked about this lesson. Can you actually now tell me, find the surface of torus, where r is the distance from the center of the torus to the center of the tube, and r is the radius of the tube. So use pi for entering your answer. So you can actually, when you enter that question, you can actually use online with a simple mode, an equation editor will pop in, and that's where the students will be able to enter a variety of responses by using the palettes. And instant feedback will then give the ability to explain that. And now you can see that in this instance, my feedback is much more detailed, much more graphical. I can say to the students that, hey, on the torus, placing a circle of radius r at the point 0 and r, and rotating it about the x-axis, this is how the donut or the torus will look like. And the equations for that will be given as a step-by-step learning right here. So see how detailed, this is almost as you're learning or teaching in a real-time environment by using pen and paper. This is another example that we utilize that for example, in a projectile motion that we use. This is a good example to highlight that you can bring third-party embedded programs into MOBIUS as well. Again, projectile motion has been part of the curriculum for many years. We've been teaching that for quite some time. What MOBIUS does, it allows you to actually teach that lesson in a very sort of a STEM environment. So you can create your text material, your notations, your equations, your plots. And once you've done that lesson, you can actually embed, which is a PhET simulation, into the MOBIUS. And by using the PhET simulation, you can explain the concept of how that projectile motion actually can be visualized, and you can then have the ability of inserting the certain parameters and then be able to produce that simulation that how the velocity vectors and air resistance could actually affect the projectile motion. So it's very sort of interactive, bringing this third-party PhET simulations into MOBIUS as well. And again, some of the question parts that are skipped quickly due to the time limitations, those question parts will be able to sort of given to the students, and you can see that the ability to see that instant feedback is available in the MOBIUS platform. Okay, I just want to check with Raymond now. I think we're going to showcase some question types and content repository as well. I just want to make sure, Raymond, will you be able to access your screen now? You'll be able to showcase your screen? Can we hear him? No, we can't hear you. Okay, in that case, then I'll continue sharing my screen. That's not a problem. Let's do that. Let me just do that. Okay, so Dr. Nomi, just let me know if you don't see my screen, because I need to open a few different screens. Just let me know if you don't cross match my words and my screen. So do let me know that. Okay, so let's take things further now. I mean, you can also do interactive narratives, which is a very important element in our teaching, in our online teaching. Interactive narratives makes things easy where you have the video slides, but in those video lessons, you can actually have pop-up quizzes. You can ask students quizzes. Dr. Nomi, can you see my MOBIUS strip interactive narrative slide? Yes? Okay. So here is now that we have a videos given as part of a lesson. And the idea here is that the instructor will run the video, It's got the whole bunch of videos, the bunch of slides, which are in a video stream. And once the concept is explained, the instructor can actually ask the student an instant question while the slideshow or the video is in action. So you see now here, I can give the students to explore the concept. So if you use traditional PowerPoint style tools, they have a setback. They won't have the ability to bring your maths notations or equations. And the second part would be what I mentioned earlier in the limitations, that it won't have the plot or a visual plot that allows you to actually show the students in a blended format. For example, if the students are listening to my lecture from home, I can actually let them to explore that. Each and every student will have the access to this lesson in a browser, just like I have the access through a browser. So they can actually go and they can use their sliders, and they can actually see how in this MOBIUS strip, how the R and T and W can affect the MOBIUS strip itself. Okay, so students will have the access to it. So if you're an instructor and you're developing your lessons online, you're trying to bring your contents online as an engineer, as a mathematician, this slideshow mode gives you the flexibility to bring that interactive elements online with an ease. And once you have given the student to explore it, give them 5 minutes to explore or 10 minutes to play. And he says, okay, now that you understood this concept of parameterization in a MOBIUS strip, what effect does increase a parameter T have? So you give them a question right away. Again, this is in a presentation mode. And every student will be able to sort of answer that question, and instantly, instant feedback will be given. Now, keep in mind that if you're running this lesson live, or you would like those students to answer those questions, and you don't want them to give them an instant feedback, you can always set it up in a policy, and these questions could be gradable. And those grades can be pushed back into your grade book, something that you can actually have published later on. So it's for sake of simplicity and an example in our presentation currently, we just set it up as a how did I do button, which gives an instant feedback. But you can obviously turn this off and have those assessment questions presented here. And those questions will then be gradable. They'll be graded automatically. The feedback will be pushed into a grade book. And you can publish the feedback either on an individual level or on a class level later on, or you can push those grades into your LMS system. You can then click the continue with your lesson that you have a plan, that I have a plan to run this lesson in my material. I can continue with that. For sake of demo here, I have inserted another question here saying, how many faces does the surface have when the parameter T is equal to 2? So the students will have to answer that question. And again, if you do that instant feedback, and if the answer is correct, you get the correct feedback, and so on and so forth. Once again, I'm just going to highlight that the feedback can be inserted here based on the instructor's choices or instructor's plan, because we give you the access to the platform where you can design all that material. Again, another question. Now, I just want to move on now. You can also have, in terms of this interactive slides, you can have a lot more interactive elements. This is a very interesting...
So let's go back to this idea of integers for a second.
Explaining. I'm going to mute the instructor so I can speak on top of it. You see now, in the slide, we have an equation editor. So this is something that you can't do that in your PowerPoint slides or any other slide ways, because STEM notations needs to be part of the presentation slide. So I am presenting online to my students, and even being in the class, for example, if I'm in the class and I'm presenting to students and I would like to explain them what improper fractions are, I can actually use the equation editor in my slide. So this is my slide. If I click on my slide view, you can see that my definitions and my different slides, I can see those slides in a whole series. I can see all the slides here, okay? But if I go back into my individual view, I can go into my single view slide. And then if I need to navigate, I can navigate through my slides as well to what level that navigation I need. So it does give you the flexibility of how you would like to structure your delivery or your lesson. But what I was saying is that having the ability of these palettes, which comes in a PowerPoint, in your slide, when you're presenting in a slideshow live, is a great flexibility, because students can actually enter matrices online while you're actually teaching them or while your lesson is in action. And that's a great flexibility. You can ask them to enter a variety of maths live into the equation editor while your slides has been set up. So these tools make your digital learning or digital lesson delivery a lot more easier. And from a student perspective, a lot more interactive. So you can now continue with that with that lesson, and you can see that at some point when you move on, it gives you the ability to sort of insert questions later on. You can have a step-by-step solutions. You can use the navigations to do that. You can use the sliders in order to set it up to explain how those fractions can work. So really, the idea is to construct those material with some sort of a simulation and interaction. Okay. Now, the platform does give you the access to a variety of question types that I mentioned earlier. So just to give you an idea how many different types of assessments that you can set up, I'll just take you through some of those assessment types before we go into the content repository and ready to use contents area. Variety of question types, numeric question types. You can set up numeric question types easily in MOBIUS. You can have, given the ability of randomly generating these questions. So this question asks, estimate the length of a shadow cast by 104-foot building when the sun is 75 degrees above the horizon, round the response to the nearest foot. So when the student can enter in a specific numeric format, you can have the input field in that. You can also give in terms of variety of units. Now, because of the robustness that it has connected with the symbolic engine of Maple, the units can be, as long as they are correct units, the conversion of units could be all looked after by Maple itself. If the question was in centimeters, but the student has answered in meters or millimeters, the system is robust enough to make sure that the correct answer is being marked and the wrong answer is being penalized. So those robustness in terms of measuring units, confirming those units are correct, is all flexibility available in MOBIUS. In terms of formula-based questions, and now I know that this is part of many academics who teach formula-based material. MOBIUS gives you the again what I mentioned earlier in terms of the equation editor live. So you can construct your formula-based questions, which has the logs, the trigonometry, the physical units, the equations, the formulas, the ordered list, and you can even have the multiple part questions as you would like to sort of set it up based on your assessment techniques. You can set up Maple graded questions. That means you design the question or the question that we have designed for you in our lessons, in our curriculum. Maple can grade those questions automatically, okay? And this is very popular in engineering mathematics. When you teach engineering mathematics where the limits are, derivatives are, integrals are, matrices are, sets are, and, again, giving the students the ability to answer the questions in a natural math notation. Students can actually switch between the different in a different input method. So equation editors are very popular when it comes to entering by click and drag or tapping. And if they want to go back into the input, which is a static input, they can just click on it and they can swap in between that. You can also see that in terms of, you can also give them the ability to sort of enter by palettes, and they can even visualize a plots to see that if some questions needs a plot, they can actually plot that and be able to preview that before their submissions. So that's a great tool when students have been given a STEM problem or a mathematical problem or an engineering mathematics problem. So it's available in a same smart device by just clicking on the given P button. You can give the students the variety of multivariable function plots. And again, this is a Maple plot, which has been brought into MOBIUS so that the students can see complete the equation for this function of 2 variables. Students can choose the equation editor and enter the responses accordingly. Here is now the example of what we said earlier, a chaining question or an adaptive question, where the assessment is not just about right and wrong or correct or incorrect, or you grade it and reward it or penalize it. It's about breaking down the problem and be able to then let the student steer into the area where a problem is multi-part or multi-step problem. And that adaptive progression happens as the student progresses in solving that problem. So evaluate the following integral. Now, this is a multi-integral question, and there's multiple steps involved in that. And we just want to make sure that as a student solve that question, we capture those steps and mark automatically and produce the feedback automatically. So in this case, when the student has been given an answer and the student actually has given a response, the response is wrong. Now the MOBIUS has split that problem into parts, and it says, okay, can you now solve this by part, because your first response was wrong. If this response was correct, it will then progress into the next step. But because the response is wrong, it's going to take the student backward to the prerequisite concept to break down the problem. And this is very important, because if you look around how we teach STEM education, it is very important that the student has gone through a rigorous learning. And that rigorous content or the rigorous assessment, which is a step-by-step learning, is captured through the platform. So here now, that problem is now breakdown into, hey, can you now solve that for the first product first, for the UX? Do you know what the first product is? The first step is to identify that we are integrating a product of two other functions. And with that, you need to solve the first derivative of that first. So once they solve the first product, then they go into the U prime, and then they go into the V prime, and then the VX. So you see how the problem is now broken down into step by step before the student progresses. So this is a great technology that we think that it's a state-of-the-art technology that we have embedded into MOBIUS, which actually allows a student to learn step by step and capture the progression by the system itself. Graded automatically, questions randomized, and it makes the learning and assessments a lot easier. The next is a sketching technology, what I mentioned earlier. This has been used for teaching lines, logarithms, exponentials, intervals, inequalities, piecewise functions, absolute values. So those topics are being used by using the Sketchpad. Now in the Sketchpad, you can now ask the students to sketch your response. So the following sketch shows the equation of x squared. Can you do x squared plus 4? So students have to actually grab the point and be able to sort of insert that. And basically this is a parabola. So you need to actually, the students will have to design a, let me delete that and delete that. So the students have to sketch the answer. So it gives the students a ability to sketch things online and then gets graded automatically and see the feedback. In fact, actually, if I go back in here, I should have used the how did I do button, which was part of the demonstration here, because you can turn this off if it was a quiz or an exam, and if you don't want to publish the feedback automatically. But you can leave that if it's a practice and drill. So this how did I do button right here, it gives you an instant feedback, and it gives the student an automatic response to it, so that he can see that, hey, my answer was wrong, and the correct answer is x squared, and move the curve 4 point up, x squared plus 4. So you can have this instant feedback given to the given to the student right away, or you can publish that feedback later on, depending on the nature of the assessment that you're designing. This is an interesting question for clickable image question, which has been used in a variety of. First example is a computer science example, where we have asked the student to find the code which is not working correctly. Can you pick up the incorrect line of code? So students have to go through it and then say, hey, this code is not working, or this code is not working. And then they can click it and they can then be marked automatically again. This question is then marked automatically. So you see that here, how the system has actually marked that and said, hey, your response was that, but the correct response is given underneath. So this is what we call it as a clickable image question. This was mentioned earlier in my PowerPoint slide. This is a more real-time example in MOBIUS, that this is a free body diagram questions, these assessments where students have been given a variety of forces, and we ask the student, hey, 3 boxes are attached by ropes that pass over a pair of massless, frictionless pulleys. can you please draw a free body diagram for each box? So the students has to actually enter the feed and then enter the parameters and design the appropriate forces. Again, these questions will be marked automatically. So how did I do button, which is part of the demonstration here. When you look at that, it actually marks a question based on the response given by the student and what the correct response will be. This question was mentioned earlier in one of our solar system examples, so I'll bypass that. And then if you are going into variety of other question types, like the multiple choice questions, you can design multiple choice questions easily. You can design multiple selection questions easily. You can design true and false logical questions in MOBIUS as well. You can design the drop-down questions and then continue with sort of your matching questions that you can design. Just the covering all that other areas of assessment questions that you're well known about it. With the fill in the blanks question. You can do that. Essay region question, you can ask the students to write essays. The essays have the equation editor available for them. So if in the essays you would like them to enter mathematical expressions, you've got this equation editor available. The students can enter their mathematical expressions and equations. It does have a LaTeX interface in it. So if by anyone who is more fluent with LaTeX or they've done any work previously in LaTeX, in our content repository, you can actually insert your LaTeX code, copy and paste in it, and it will read the LaTeX file, LaTeX code in it, which either it's LaTeX or MathML, it will read that input as well. Once the student has submitted the assignment, now a message will be given that you have submitted your assignment, and these are the questions that you haven't answered. The final grade will be the grade because it marked automatically. It gives you the details, and when you click on that, this is again based on the instructor policy. If they would like to publish that instantly, it is available instantly. But if you like to give this detailed feedback at later point, you can set it up as giving that on a scheduled time. For example, that feedback has to be given in a month's time or a week time or a 3 days time before the instructor can review that. So you can see that the response which was given and the correct response and the response that the student has submitted is both given, and it's automatically graded and giving all the grades details in it. And in fact, partial grading is covered. We'll be able to see the partial grading here in that adaptive question that we're trying to solve in a step-by-step method. You've got the one step that you've got wrong, so you've got the 0 in it. But then when we started to break down the problem, each step has a grade. And in that grade, with a partial grading, you can actually then penalize a student or reward the student as you progress towards solving the problem step by step. So the total grade, which is an accumulated grade of this question, will be a combination or accumulation of each steps that were involved in solving that question. So the system can actually mark that on a step by step. So these are the great tools that are available, which uses it really feels like you want to deliver your lessons in whether you're on campus or off campus. It gives the instructor a great flexibility to design these kind of assessments and lessons fairly, in an online space. Okay, good. So this is the feedback. Now I've seen the message coming from Raymond that he can actually now take over on the presentation to take you into the content repository, show you some more examples of contents. He's got some examples for circuit-based questions and for the electrical engineers. So Raymond, can you now share your screen? Can you still hear us, Raymond? No, we can't hear you. Yeah, cannot hear. Yeah. No? Okay, that's all right. That's not a problem. So I will then continue. Let me just do that. So, okay. So let's go back to my screen. So with that now, one of the things that we need to see now is to go into the content repository and see what we mentioned earlier. How easy it is to actually, construct some of this material. Now, before I go into the content repository, if you see that, Dr. Nomi, can you confirm that you can see my content repository? Yeah? Okay, great, excellent. So before we go to the content repository, I guess it'll be good to see what are our current content packs that are available in a ready-to-use mode. So let me change my screen and make sure that you can see my screen. There you go. And then I'll stop that. Okay. So these are some of our content packs that are available to use instantly. And when I say instantly means as soon as you have the access to MOBIUS, you will have the access to all this contents and material. Okay. And each unit that we give you part of the access to these contents are structured. Now, they are structured based on course information, units, and then each unit will have the assessments. Those assessments are designed for you, and it comes with the exercises and answers. So each section that you will see in those topics will have navigation. As you can see, the navigation bar on top of it. You can go through those material and you can say, okay, we do teach ratios at university, and that might be used for multiple instructors who use this kind of concept. Now, because we give you the access to do the editing and modifying and cloning and changing, because these contents are not locked, you can even have a collaboration between one instructor and another instructor. So one instructor who's using ratios to teach in his class can actually share the same material in another class. So once you go into those lessons, you can see that each lesson now is structured. You have the videos and audios available to utilize as a ready-to-use course. Again, because they're modifiable, you may want to choose this topic into your different subject, for example, or in a different unit, for example. So you can move around, you can clone it, you can change it, and you can use those as per your need and necessity. Once you run those material, they all have
calling their friends.
I'm going to sort of stop again. That in the audio of the instructor. Again, you can open up these in your content repository, which I'll showcase later on. But this material is pre-designed, and you can again see that same functionality what mentioned earlier, that you can see the full slides and you can say, hey, that topic of ratios looks really good. Do you know what I'm going to do? I'm going to use that in my current course, and I don't need, for example, this, or I probably need three in my unit, but I don't need the other one. So you have the power of picking things the way you would like to do in a local delivery format. You can give that into an alternative format. Alternative format obviously is not the slideshow format. This is more likely if you would like to do that in a handout notes format. So you can give that in a handout notes format. You can do that send them in an email. You can do that in a printout format. I know in some cases they ask, oh, can we do that in an offline, for example, if we don't have the access to internet, for example. So if the students are in the area where there's no internet, as an instructor, you can actually choose that as an alternative format, do that in a printable format or in an email or in a PDF, and obviously send that organize the access to them in an alternative format. The only thing that you need to be aware of that is that when you go into the printable format, our animations and simulations and interactive elements and interactive contents will not be as fun. They will not be sort of used because obviously they are in a printable format where we would like the students to sort of gamify, use the controllers, use the sliders to be able to sort of engage with the content. So that engagement will not be as when you use this material in an online fashion. Those questions are all part of our modules. So when you go into that, you've got questions, pre-designed questions that you can use that, and those questions can then be used in part of your delivery. And we do use some of those assessment techniques from a GeoGebra as well, which is one of the other third-party tool that can be embedded in that as well. So students can actually use the sliders and be able to answer the questions and then be able to say, hey, how did I do with that? And that feedback will be given instantly. That's wrong. The picture shows to have 16 spectators, 12 basketball spectators, and the football. So you see how that interactive questions are, which has been a combination of images that we have got, plus the bit of a GeoGebra's app in that to make it a fun. As an instructor, you have the access to the answers and solutions as well, so that you can go and have a reference to it before or after your delivery. So this is one lesson. I want to go back into the list of our contents This is just the one example that I've shown you. Obviously, there are other examples. For example, differential equations course, which is again a very popular course that you would like to see in your School of Maths, I believe. If the engineers do come in your faculty and they learn maths and differential maths, this is again a complete structured course with the quizzes built into it, right? So this is weekly quizzes planned, week 1, week 2, week 3, week 4. So you've got this 11-week complete structure, and those quizzes can be then used part of your, for example, differential equation course. So this is again another very useful course that can be referred to immediate use. Course on physics, for example, physics, mechanics, waves, and acoustics. This course is a bit, again available, for delivery. You've got the chapters completely structured, completely ready to go, and then obviously you've got the appendices with the assessments in it, and each one is again available in a mode that you can actually start delivering that in a blended format. And I'm using the word blended format because these courses are available in a digital format. They're available online, but it doesn't mean that you can only use it in an online. You can obviously download this material and then distribute that to the students, even if you would like to do that, sort of an off-campus readings and off-campus assessments. Right. So now, with that said, I'm going to go into the repository now, and I'll show the content repository that content repository look like. Just bear with me. Let me just open the right screen. Okay. Can you see my repository screen, Dr. Nomi? Not yet. Okay. All right. So let's do that now. Okay, great. There you go now. So just to give you an overview of that, how as an instructor you have the access to the platform and the content repository. So if you see on the screen now, when you log in as an instructor into MOBIUS, it gives you a full navigation space. You have the access to the sources. You can grab material from our cloud. So if you click on MOBIUS Cloud and you click on your variety of lessons, it will download variety of lessons which are available. Now you might see there's other languages because, as I mentioned that earlier, our programs and our products are available across the globe. So you might actually find some funny material in that as well because it's a public domain. There's a material from in Chinese language, in French, and other European language. This is where a lot of our Maple and MOBIUS community share their assessments and their lessons and assignments and things. They are available for you to use, by the way, because they share it as an open academic community, so they can utilize that. That's the cloud part of it. But also, if you have been given the access to what we refer that are content packs, like the starter content packs or any other content packs, then that option will appear here. And once you click on it, it will give you the access to all of your contents that has been subscribed under your institutions. And I think, to my understanding, currently, as much as UiTM has the Maple licenses, UiTM also have the access to the starter content bundle here, which are the content list that I was mentioning earlier about the algebra and calculus and differential equations and physics and acoustics. Those are available for UiTM to see that on the server right here. Now, in that source, once you've decided that what you're going to sort of use the source for it just navigates itself then. The navigation will be then you go into, for example, you go into my classes, for example, and then you can see that, okay, there's the lessons. Okay, once you've got the lessons, what else do I have? Lessons clone into my classes. Or can I see my assignments? Or can I see my question types? Or can I see my content pack samples, you see? So I can navigate through what that lessons are available for me. I can go into what my current class is or what's my ACES MOBIUS demo class is. I can click on it and I can see that how many variety of lessons are available for me. Let's open up this Taylor series lesson that I used earlier, part of my example. You see, it gives you slideshows, what you want from the slideshows itself. It gives you a list of slides, and now it becomes available for me to clone and done. And this is a lesson that I was trying to mention earlier in my showcase class. Remember that? So you now have the ability to run these lessons as part of as an instructor. So you can actually see how this will be available for me to edit and be able to sort of clone and edit on that. So if I use that, these were the kind of questions that I had. So as an instructor now, I can go and use the examples and see how my material will look like before even I publish that in an online space. Okay. And once I do that, as an instructor, when I design my questions like this, I can actually use that and test that. And I can see that, okay, how my solution to this, we know that the derivative of n x is equal to that. How will that work for me? I can click on a grade and I can see that how the feedback will look like before I publish that. See, this is my adaptive question. I can see through as a step-by-step in terms of the mechanism which is involved in that. So as an instructor, you have these tools available that you can view your material. You can actually test that material, grade that material, and then be able to then publish that material in an online space. You see? So it actually gives you tools that you can actually test and try and then be able to publish that in an online space. Going back into my, for example, creating into the lessons, if I go into starting something from scratch, I can go into my lessons and I can say, okay, what I'm going to do now is, for example, change my mode here from source into all of my classes. I say create lessons. And if I can scroll down and I say, for example, mechanical eng or demo content, basically lesson possibilities, and going into my class, I can have it. I think this is, for example, McLaurin series question that we had earlier. So I can view those questions easily in my content repository. Now let's do something new. For example, I need to create something new in my MOBIUS. Just hang on a sec. I have to go back into my main class here to go into my sandbox to have a better access to the new elements. If I see create new now, look at this now, it's given me much more options now. I can create a whole new lesson. I can create an assignment, adaptive assignment, question types, math apps. I can create that new material as much as I would like. So, for example, if I need to create a new question, for example, the editor is what you see, what you get. It's a fairly interactive editor. So I can say Q1, and now if you see, I've been given all the editor functionality. I have the tools that I need in order to set up the text. So I can type the questions, and I can type the text and use the equation editor to insert my maths. Okay. So by using that power of equation editor, I'm not restricted to a word editing mode only. This editor gives me the word options that I need, alignment options, and then along with that, equation editor, which is the maths options. I can insert the align environment the options. I can enter the variety of STEM symbols that we have, the math mode symbols as an equations. I can enter those math modes and text mode, how that look like. So I can insert those modes so that I don't have to look for a LaTeX input, basically. I can insert those math symbols easily. I can insert my videos. I can insert my external contents, third-party contents. I can insert images. I can insert hyperlinks. I can insert tables. I can insert horizontal lines. So these options are available for me as an instructor. And then I can insert the response area that I need. And now in this case now that, for example, if I'm trying to design a question which is a formula-based question, I can choose the formula-based question, and interactively it tells you what weighting you need in that area. What kind of formulas that you're trying to insert as a subtypes. These will be, for example, formula without the logs, formula with physics unit. What do you need any chemical equations, for example? So in terms of chemical equations, it'll then give you the options to choose the chemical equation formats, for example, or other mathematical formats that you require. Enter the answer. In terms of feedback, if you remember that I mentioned earlier, that in terms of feedback, it gives you what you see, what you kind of editor again. So your feedback will now be as much as you can author your feedback. If you need a texting in feedback, if you want the graphical or animations in your feedback, you can insert that because your feedback editor is exactly what your question editor looks like. And underneath that, when you've designed your question, you can then have the algorithm generator. Remember that? This is the one that I mentioned earlier. You don't need programming skills, higher programming skills for that. You can use a show designer, and then you can choose what variables that you're trying to randomize in your question. Is that going to be, say, X is a random, a whole number, or do you want to do floating points or decimals? And then with that, this will be between number 1 and 100 in the steps of 2, for example. When you click add, you see under the algorithm designer, it inserts that programming code automatically. So as an instructor, as a STEM instructor, you're just using a small little GUI that allows you to insert your code itself. Okay, you could actually set up the conditional statements, for example. Is set to be, say y is equal to, is set to be if an equal signs, the one we do as a boolean, is set to be, say, 10, to be 10 if, say, x equals to 4. Otherwise, it's set to be 5. And when you enter that, it will then enter those Boolean conditions automatically, part of the algorithm generation. So now I'm not going in a deep, considering the scope of this presentation, but the idea is that in this presentation is that these tools are available for you as an instructor to design your assessments, lessons with the power of Maple being running behind the scene. So in MOBIUS, there's a built-in Maple which allows you to access those commands. And when I say Maple is what I mentioned earlier. This is a Maple which is available for within MOBIUS for your symbolic corrections. Now you can construct your cascade style sheet so that it should look like to what your UiTM website is. So you can your IT administrators can enter that code, and obviously the feedback that I mentioned earlier. I have been given a notice because obviously there's a number of questions in the forum as well. So what I want to do is, just as a last example on this side, is that to show how easy it is to develop some of those contents bringing from Maple into MOBIUS is, for example, I want to bring one content that I did earlier, and then we'll probably stop the presentation there. So what I'll do is I'm going to close these documents that I had earlier. I would like to bring, for example, one of the app, from our Maple tools, that those apps are available. And maybe let's just pick up one of this app that I was mentioning earlier for the electrical engineers. If you open up this app Oh, sorry, my apologies. Yeah, sorry. I'm going to switch my screen now. Sorry, I've got multiple screens here. Just share with me, bear with me. So there it is. I'm going to do, so this is the app that I mentioned earlier that we showed that for the electrical engineers, which is available in Maple. This has been designed in Maple. What I'm going to do now is to bring that from Maple and spit it out into MOBIUS so that my lesson on diodes is ready to go. So I'm going to do that, and then we'll probably finish out the presentation right there. So what I need to do is simply save as. I'm going to put this document here in my folder, and I'll make that as simple file. And what I'm going to do now is change my screen and bring that into MOBIUS. Just bear with me. So I'm going to do stop sharing and share my MOBIUS screen. I've got a couple of different screens here, so I'm going to do share. And let's go to the MOBIUS screen here now, share it. So this is my share. Bringing those apps into MOBIUS is as easy as just a simple clicks. So response area, click math app, and you go and you read any worksheet that you have done in Maple or any app that you've created in Maple. You go navigate that, choose a file, go into my desktop, try one, open that, and then say click OK. And once that's in here, try one. And what you need to do is simply insert that into your MOBIUS. And once you've inserted that, it's ready for a preview. So when you preview that, Dr. Nomi, can you see my preview window? It says diodes, yes. Can you see that screen? Yes. Okay, so now you can see that all my expandable and unexpandable section of my explanation what the semiconductors are has actually brought into the browser automatically, really. It actually brought in inherited animations that was part of the app itself. And that's where the magic of this platform is, with a combination of Maple and MOBIUS, that you can construct some of these very highly For this, we don't need massive programs to run that. It was available in Maple 2022. We brought it straight into MOBIUS to run that in an online environment. So alignment, animation is all completely live in the browser in a MOBIUS environment for you to deliver as a lesson. I can construct a math upgradable app next to it with the assessment. Obviously, that is something that we can probably leave that to the next seminar. And that's where I think I should stop and take some questions now.
Okay, thank you, Dr. Asim, for an interesting talk and your valuable insight. Okay, so for all the participants, if you are interested to learn more about Maple and MOBIUS, we will organize a free training of trainers workshop, but only for your UiTM staff to learn about Maple and MOBIUS, inshallah, by the end of this month. Okay, and an official announcement will be made via UiTM email and also via the COE Google site itself. Okay, Dr. Asim, so I think we can allow maybe only 3 questions. Okay, so the first one comes from YouTube, which is from Mr. Pravin Kumar. Okay, so good morning, Dr. Asim. So can he use the Maple or MOBIUS to solve lead-driven cavity?
Right. So the answer is yes.
Okay.
The short answer is yes.
Can I read the second question first? Okay,
yes.
So the second question comes from Puan Siti Salma. Okay, so she asked about, can you show the demonstration if the given answer, the student given answer is wrong? So what is the pop-up window that we can see?
Sorry, can you repeat the second question now?
Okay, if the student give the wrong answer, so can you show the how the feedback looks like?
Oh, yes.
And then the third one is the last question is, can you share your experience in implementing MOBIUS in universities, maybe in Australia?
Oh, yes. I mean, definitely. I mean, our experience with the universities is that currently our major university, you've asked questions specifically with Australia, University of New South Wales, which is one of the large university in Australia, has been using MOBIUS and Maple for many, many years. And their current exam structure is, out of that 35 million assessments that I mentioned earlier in my stats, they have close to 12,000 students, which run through their assessments, throughout the term. They conduct their final exams in MOBIUS. Their teachings are done in Maple, what you've seen earlier. Their lessons have been designed in MOBIUS as well. And we are getting a lot of positive feedback from their academics that it has actually made the overall process of publishing the contents a lot easier, because you can develop, deploy in a shortest time possible. And again, mentioning that a lot of maths instructors are not programmers, a lot of engineering course instructors are not programmers, and Maple and MOBIUS has made their life fairly easy from concept to delivery.
About the lead-driven cavity, how can we use Maple? And the second one is about the feedback. If the student give wrong answer, so we want to see the feedback, what it looks like.
Right. You want to see what it looks like? Yeah. So I'll probably have to then stop the screen. The question on that cavity, I think that's something that we should discuss that offline, because that instructor who's trying to design that, the short answer is yes. But obviously, if the instructor is after some examples, then maybe we can send you some examples after the meeting, which you can share it with the instructors later on. So the first question answer is yes, but I think we'll probably have to take that offline to show him some examples to do that. The second question is where the instructor has said that if the student has done wrong, how can we show them that answer is wrong? I think for that, you probably have to look into an example of that adaptive question that we mentioned earlier. And I think that could be a good point to see how we could actually give that feedback. In fact, that Taylor series was actually a good example too. Where's my, showcase class. Showcase class. So if I go back as an example, so let's take the last question. So when we enter, let's take this example where the student has been asked to enter a response. And when the question has been marked, the feedback has been given to the student, right? This is the small feedback given to the student, right? So is this a question that the feedback has been given to the student? So the answer is yes, and this is how you can show the feedback to the student that this is wrong. Am I missing something in that question? I think so. I think that's something that we have to sort of have that response ready. But the answer is yes, but we may have to take that question offline to be able to show that how that can be done.
Okay, so thank you, Dr. Asim, for your response for all the question. Okay, so again, we will conduct a free training of trainers workshop, okay, for Maple and Mobius for UiTM staff. So stay tuned for the email and announcement. Okay, so what I can see that Mobius, which has Maple engine behind it, really support the STEM education. Okay, so the best feature is it can automatically generate multiple questions, and it is auto mark where student can get the immediate feedback. Okay, so there are also a bundle of starter packs where lecturers can edit and modify, so they don't have to start from scratch to fit their own course. Okay, so and then since it is an online platform, it can also support collaborative content development and also assessment. Okay, so Dr. Asim, I would like you to and Raymond, maybe you can switch on your camera for the photo session. Mr.
Just on
Raymond?
that point that Dr. Nomi mentioned, maybe if someone can copy and paste and send that link to everybody, this is where we have a whole list of packs that people who are interested to see what packs are available to use instantly. That might be the link that one of the moderator can send that link to everybody. Then that would be great.
Okay, so this is the starter pack, and I think we also have this link in our Google Sites for the Center of Excellence.
Very good, excellent.
Okay. So Dr. Soila, can you help to paste the copy and paste the link? Okay.
Yes, I can do that. So bear with me. Where is a chat? There's a chat, so I can just copy and paste.
Okay, thank you. Okay, and then for the photo session, but we can open the photo session to all the participants. Okay, so it's only for 4 of us. Can Mr. Raymond and Dr. Sohaila, could you please switch on your camera for the photo session?
That's interesting to have a photo session, obviously in a WebEx environment. Feels like having a physical photo.
Oh, okay. Raymond, camera doesn't work. It's okay. Dr. Sohaila?
Okay.
Okay, so smile, 1, 2, 3. Okay, thank you.
Very much.
Okay,
really
thank you
appreciate
for
it.
your cooperation. Okay, for all participants, don't forget to fill in the feedback form. Okay, so we appreciate if you could provide your feedback. Okay, and then on behalf of the Faculty of Computer and Mathematical Sciences, okay, and our presenter, okay, we would like to thank all of you for joining us today, and also thank you very much, Dr. Asim, for your sharing session. Okay, so we look forward to see you on our next event.
Thank you very much. Really appreciate it for organizing this.
Okay,
thank you very much.
Our next event.
Bye for now.
Assalamualaikum.
Wa alaikum assalam wa rahmatullah.